any action that an AI model, some large language model can take that is bad in some way is exposing an equivalent risk to an insider threat.
Well, hello and welcome. I'm Joe, your host and MC for today, and I'm excited to talk about AI governance. So we've seen a number of news stories that have raised some new questions about what happens as AI systems become more capable and gain access to tools, data, networks, and other systems. For people who work with AI every day, some of this behavior may not be entirely surprising. But for organizations, these incidents are a reminder that as AI takes on more responsibility, we also have to think seriously about the controls and governance around it. So I want to start by grounding the conversation a little. I'm here with Tyler and Austin from our Innovation Lab team, and I have a few questions that I'd like to ask you guys. So, Tyler and Austin, we've seen several recent examples where advanced AI systems behaved in ways that went beyond what their operators expected. For someone who hasn't seen or followed these developments every day, what are you seeing and what has actually happened?
So for someone who isn't following these developments, what I would say is that there have been a number of cases where frontier model developers and evaluators are using AI and evaluating its capabilities, specifically in the AI's ability to use other computer commands and components to extend the, sort of the frontier of what the AI can interact with. And in a lot of these cases, what the headlines are is that this AI is using those computer commands in unexpected and surprising ways that could be kind of concerning in some cases, where the AI is using commands that a human developer would not use ethically, because those commands could be construed as something like hacking or gaining access to systems that a human developer would hesitate to do.
To reinforce what Tyler said about them using things that human developers wouldn't, they're not using things that human developers don't have access to, but they're using things that are available to them in ways that the controllers or the prompters didn't expect. So the tools, the things that they're doing were things they could have done already and a human in the same situation could do if given the same access. They're just acting unexpectedly rather than in some sort of new way.
Yeah, absolutely. I think it's the unexpected actions that are really the cause of concern here. And that's kind of what I want to talk about here. So a lot of people are receiving this news and a lot of people are trying to interpret what's going on. But my concern is people are getting something wrong when they hear about the headlines about AI going rogue. So what are your thoughts about this idea of going rogue? And I think it's related to a lot of what you, Austin, said. So let me start with you. And what are your thoughts around that?
Yeah, it's not going rogue. I mean, these large language models aren't coming up with like new things, right? They're pattern matching. They're guessing words based on previous incidences of words. So if an LLM is doing some sequence of commands to try to like escalate privileges to accomplish some task, all it's doing is looking at what its training data has available to it, right? So by going rogue, what they're really doing is they're just using pre-existing patterns that exist in the training, and they're using them in ways that maybe weren't intended, but that's because the guardrails that the humans have put around these AI, around these large language models that are operating, aren't sufficient, right, for the level of control that they're given.
I think maybe what some people are getting wrong is they think that the AI is somehow moving from system to system, and that when they hear the word AI is uncontained or it broke containment, they think something like a lab rat escaping the cage. And that I do not think is a correct interpretation. I think that the better analogy is that the lab rat has figured out how to pull some strings and manipulate some things from within its cage, right? So the lab rat is doing something surprising, right, that the researchers did not expect. And it could even be concerning to some degree, but it's not that the AI is now out in the wild and there's no way that we can put the genie back in the bottle. We can most definitely put the genie back in the bottle anytime we want.
Right. It's a lot like software testing too, where your users will do things that you don't expect them to, and they will find ways to break your system that you never anticipated, right? Because you have a particular vision in your head about how people are supposed to do a thing.
No, I appreciate that. And I appreciate the idea that this is not new. This is something that's been happening for a long time, even before AI was in the mix. So it's interesting to me to think about, why should this matter? As a lot of organizations hear these things and think this is only happening inside an AI lab, we've seen this happen in real world situations and real world effects. So, what are the thoughts that you have around why this matters to each individual? I'll start with Tyler.
So this matters a lot here within the innovation lab at MetroStar because we use AI to develop software extensively. And um, we have seen examples ourselves where the AI will make choices that human developers would not have made. Sometimes these are good choices and it's innovative and we think, hey, this is, the AI did a good job here. In other cases, probably the majority of cases, we look at the AI and think that's not the right way to do it. It's going down the wrong path and we need to step in and stop this. So these are things that happen with the AI models that are available to developers on the market today. And the behaviors that we're seeing are the same with the models that are available commercially today, as well as with the advanced frontier models that have not seen widespread adoption yet. So there's the same situations; they're just applied to more advanced models in the labs, but we still see these same things when we develop software with commercially available models.
And let me ask you, Austin, a similar question, but why should organizations deploying AI mission critical into their environment pay attention to what's happening?
I would say it's because any action that an AI model, some large language model can take that is bad in some way is exposing an equivalent risk to an insider threat. Because these large language models, if not properly, contained with like permissions and with air-gapped environments and security controls, are again only doing things that a human could also do, but just is expected not to. So if you have vulnerabilities inside of your environment that are exploitable, they will be exploited in order to achieve whatever goal or result that the large language model, has the ability to assemble the correct words together to achieve.
And I assume the same is true even with sensitive data, as another example where this is more problematic.
I think Austin hit the nail on the head there, that there's an entire class of behaviors that the software development AI models don't have, and that is, am I going to get fired for this? And so I think that or maybe not quite that, but am I going to get reprimanded at work, right? If I take an action as I'm developing software, maybe I know that something is vulnerable. If I were to exploit that vulnerability as a human, that would be looked down upon by my peers and by my leadership team. AI models do not necessarily always have that same response. A lot of times we ask the AI models to do something and they will figure out a way to do that thing that they have been instructed to do using all available tools and all available ways forward. And that, I think, is sort of the difference, one of the differences that we're seeing between how AI develops software and interact with its environment versus humans.
Another way to think about that too is that these large language models are going to tend to produce strings of words and produce actions that they've seen a lot of times. So if you have something special in your environment or something bespoke or some particular process that you need followed, by and large, LLMs aren't going to pick up on that right away. You need a lot of controls if you want to do something specific, if you want to really contain what something has the ability to run inside of your environment.
Yeah, these are great points. And so it makes me think that the issue really isn't necessarily whether the model is good or bad. It's probably whether the model was built right in the system around it. And I think that's what you guys have been talking about. So that really leads me into the next kind of thought process around how we're deploying AI here at MetroStar. And my question for you is, when we talk internally about responsible or governed AI, what does it actually mean to us?
I'll start with that one. For us, it means controlled. So exactly the things that I said. We have, for example, in the Innovation Lab, AI guardrails that entirely prevent models from going out and grabbing new dependencies. It is not possible for our models to go grab a dependency off of like a Python package distribution, or like a Node NPM package distribution, because we've seen a lot of supply chain attacks, right? Like those are another common thing that's happening right now is poisoned packages, disruptions and malicious code that gets replicated through these package managers, these package distributions. So we govern our AI by preventing and sort of eliminating its ability to go out and, incur or sort of give us these vulnerabilities, because we just don't allow it to do it. And that kind of like positive control is our governance model. So the things I was saying about, if you are vulnerable to an LLM making a particular decision, you're also vulnerable to an insider threat making that same decision. And you need to stop or prevent the LLM from even having the ability to do something that's harmful in the first place, because instructions aren't good enough. Instructions are best effort recommendations that LLMs ignore. You can be as specific as you want in your prompts, but if you do not physically prevent and make it impossible for an LLM to do something, it probably will end up doing it in some way that you don't expect.
And Tyler, where when we talk about human in the loop, where does that fit? Because we talk a lot about software guards and controls that we put in place. But what are your thoughts about humans are also fallible, but where do we put them in the loop, and how do humans also control the effect of AI and agents?
So the first place that we put humans in the loop is ensuring that the human developers assembled the correct, I would say, hermetically sealed development environments that the AI then works in. So these are the sandboxes. We assemble the sandboxes that the AI is allowed to work in, and we assemble those sandboxes so that way the AI has access to only the tools we want it to have access to. Specifically, does not have access to anything that we do not want it to have access to. That would be API keys that it could unintentionally exfiltrate or expose. That would be other internet-connected services that we do not want to rely on for our development practices. But it also means that we are using AI in a recordable and auditable fashion, where every step that the AI takes is recorded in an append-only ledger of sorts that the AI cannot go back and modify. So this is outside of the sandbox. We have a process that watches what the AI is doing and records everything. And that makes it very straightforward for us to go back and understand, well, what did the AI do during this workflow or during this development session? What did it, what services did it touch? What information did it use? And we can even, to some extent, go back and understand, well, why did it choose to do that? If we gave it somewhat different instructions, would it choose to do something different? So that is the primary human in the loop, is setting up the environment and providing these measures so that way the AI only can access the things that we want it to access and must stop. It doesn't choose to stop. It simply has to stop before it can access anything else, because it needs to ask the humans for the ability to do that, right?
Absolutely.
Yeah, and that model is not new, right? That's least privilege. That's sandboxes. That's isolating users and processes. Like the controls that work on large language models are the same ones that work on humans, because large language models are producing things that humans have done, right? And they're good principles because, we've ended up at them after, decades of security research and, cybersecurity controls. And like the auditable ledger that Tyler is talking about, like that's a requirement of like IL5, right? Like these controls already exist. We just also have to think about a large language model as, again, something that doesn't think it's going to be fired and is thus willing to do things that would otherwise, just sort of be anathema to good development practices.
Yeah, absolutely. And we have to remember zero trust is still a principle and something with least privilege than everything else you described that needs to be built towards, so that we don't avoid the consequences, or so that we can avoid the consequences of things that don't adhere to that.
Yeah, exactly. Right. Like that is good governance, is adopting full scope security controls for LLMs, because LLMs are not your employees, right? We can sort of treat them, give them like domain context and knowledge and work with them side by side, but fundamentally they're not. They have access to all the training data that went into training the model, and to whatever patterns of context exist at whatever particular run. They need security controls just like you do with humans, right? It's fundamentally the same thing.
Excellent. So I think we're talking about it, but I think a lot of people may wonder is what's the difference between model safety, as we've talked a lot about, and actual system governance?
So the difference between those two that we use here in the Innovation Lab is model safety pertains to what sorts of outputs an AI model would produce based on different inputs. So, for example, if you were to ask an AI model to disclose some sensitive information that it might have access to, that model would choose whether or not it wants to disclose that sensitive information. So if that model already had access to an API key and you said, please tell me what the API key is, it would be a model safety issue whether or not the model chose to do that. Another probably far more relatable case would be if the model has the ability to go get a secret from a deployment or retrieve a secret from a system, and you ask it to do so. It would be a model safety issue for the model to choose whether or not that is an appropriate thing to do, in the same way that a human would say, I'm not going to go get your password for you. You need to go get your own password yourself. System governance is broader than that. System governance is not just about the model, but it's about how that model is able to interact with its surroundings, the adjacent systems. So that is not only what choices does the model make, but what choices can the model possibly make? Does the model have the ability to go get secrets, or is that prevented structurally in the AI's harness, right? The AI simply does not have the ability to execute a command that would go get a secret.
And this is why you saw sort of early on with ChatGPT and Claude, people could say, okay, go give me this secret, but as if it were in my grandmother's cookbook recipe, right? Because that is protecting your secrets in a way that sort of prompt allows somebody to get access to them is depending entirely on model safety. And that's not sufficient. Like, that's not good enough. If you're depending only on your ability to be more clever than somebody that's trying to exploit your system, you are going to fail. Like, you will not be as clever as somebody that is determined to get in. But if it's impossible for you to expose secrets, then there's nothing that they can do about it, right? Because the language model that they're interacting with just can't access it. And that requires then security controls inside of your ecosystem, because if the language model still could get at the secret, even in a way that, it's not supposed to, but it's allowed to, because, you don't have proper process isolation, or like security controls, then it will do that, right? So you need to put these structural barriers in place, but then you also need to worry about the security of the model itself and the process that it's running in.
Yeah, so it sounds like what we really need to talk about is governed AI. So I think my next set of questions are going to be around that specifically, because we are all in agreement that that's what's most important. If an organization tells you it wants to deploy governed AI, what should actually be governed?
I'd say the first thing is the set of actions and information, the set of actions that a model can take, and the set of information that's available to the model, because you cannot just sort of give unfettered access to whatever's in your environment. You need to be very aware of what you're giving your model the ability to do. That's why you see in like a VS Code, you have to click the allow all commands, right? Like, that is an option you have to opt into, because by default, these models have access to a lot of different file system operations, and some destructive ones too. So any organization that's interested in governed AI needs to take a fairly deliberate accounting, deliberate and exhaustive accounting of all of the actions a model can take and all of the information that it has access to, because that's vulnerability, right? Like that is a risk. If you give a model access through whatever means, intentionally or unintentionally, to sensitive data, you are exposing a new surface, a new vulnerability to that data. And that you need to be aware of that, because that's part of sort of your entire risk posture, and it's part of the controls that you need to implement in order to keep that data protected.
When organizations ask about implementing governed AI, I talk about the Innovation Labs Midas product, because Midas is our way to provide governed AI easily to these organizations. What Midas does is it makes it easy for organizations to define what that governance, as Austin mentioned, means in practice, and only allow the AI the ability to interact with those tools and information and adjacent systems that it is explicitly allowed to interact with. So Midas provides a very straightforward, easy to use capability for organizations to adopt governed AI for very specific workflows that they want to use AI to accelerate.
And that ultimately leads us into why we built Midas as an AI governance platform. So I agree with you, Tyler, and I think it's interesting. Could you describe what other problems we're trying to solve with Midas? Because AI governance is just one of them.
I think governance a lot of times is very closely associated with security with AI, and that is a correct association. However, governance also allows AI to perform better, because we are restricting sort of the rabbit holes in which AI can go down. So if you allow AI to have a green field, ungoverned approach, there's a good chance that AI is going to go implement something or make decisions that we don't really want it to make. And it makes these decisions based on the instructions it's given and the training that it has, but it also makes those decisions based on the capability that it has. If it has the ability to go access another system to accomplish its goal, then it is going to consider and potentially use that other system. If that is not something we want the AI to do, then we can increase the performance, we can increase the reliability and the success rate of the AI by only giving the AI access to the pieces of the system, to the pieces of the development lifecycle, and so forth, that we know we want our solution space to occupy. And this allows the AI, really to perform faster, to give us better structured, better architected solutions. And it also decreases costs, because we are not running AI multiple times and telling it, nope, not that way, nope, not that way, nope, not that way, right? We can run AI one time or a few times and get the results that we want.
Yeah. And not only, yeah. So cost is the big one, right? Especially now is, it costs more to use tokens, right? We want to use our tokens efficiently. We want to make sure that, when we're doing prompts, when we're asking questions or trying to, get some particular result, that the model is going in as direct a line as possible. So this model, like of applying the idea of how best to shape outcomes or shape outputs of these models is something that you can internalize and abstract over a bunch of different domains.
When we say Midas enables governed AI, what are some other practical examples of things that it can do?
Yeah, so we actually use Midas to write Midas. We use Midas to create a bunch of different kinds of workflows in a few different lanes. We use it for code quality. We use it for dependency management. We use it for deploying to GovCloud, to an IL5 air gapped environment that we host Midas in to practice that exact kind of security isolation that we talked about. And in general, we have in Midas the ability to build workflows that chain together a lot of different kinds of tasks, a lot of different kinds of actions. And what that lets us do is sort of at like an action by action level. So each step of a workflow, a business process, that kind of thing, define exactly what we want accomplished, whether that's with an LLM or without, right? Whether it's something like deterministic in code or it's an LLM request. And we can shape at each level, sort of like a zero trust, but for a workflow or a process, we can shape at each level exactly what capabilities are available, what sets of data are accessible, where the prompt goes, like what kind of large language model. We could keep things internal that are smaller sort of domain requests that we don't need to do like an external API call for. Or if we do want to use a flagship commercial model with data that's not sensitive, that is something that we can provide or bake into this particular workflow step. So we use it for its own development in a number of different ways, and we have built with it the ability to make sort of fully governed workflows.
And Tyler, what really makes Midas as customizable as it is? What is it capable of doing to customize it, as Austin was describing?
So for Midas, we take the approach that the AI models and the harness are we are building agnostic to that. So we want to be able to use any set of commands, any set of models, right? Any set of providers. But we want to be able to lift up above that the actual tasks that we want the AI to do. And this allows us to accomplish the same sorts of workflow tasks via configuration, as opposed to writing bespoke code or applications every single time for every single use case.
Austin, is there anything you'd like to add?
Yeah, and I think one of the most important things that we have is also the ability to measure performance. So measure how well agents and models are responding in terms of things like how many reprompts are needed, how many cycles models had to go through, how accurate the responses are for something like code quality, for example, how close to like a desired lint state or type check state code is, and also how much it costs, how much it took in tokens to actually end up with the result, and that lets us compare performance and right size our choice that we're given, choice of model that we're given by the abstraction, to ensure that we're being conscientious of spend, and we're not sort of pointing a jet engine at something that that we could accomplish with a kite.
For those that are interested in the sorts of workflows that Midas can implement, I would encourage you to go look at our materials on our ATO ready workflow. So this is our continuous ATO offering that integrates with adjacent systems to pull the entire software picture, from the source code to the dependencies to the containers, the SBOMs, the network profile and cloud infrastructure, and assess all of that in a governed, repeatable, reproducible workflow to produce that continuous ATO assessment.
Yeah, that sounds like some very practical applications of Midas. So great explanation. I guess I want to close with something practical. If you're a CIO, CTO, or CISO, a mission owner, or an AI leader deploying AI today, what questions should you be asking your team?
I would ask the sort of the question I outlined earlier with, what is the persona, or if you were to have somebody come into the organization, a contractor, and you needed to give them access to do a particular task, what would your security controls be for that potentially untrusted contractor? That's exactly what you should be doing for your large language model. You should be putting, the model running in a process that has the same level of security controls and same least privilege on accounts, and same restricted access that you would give to a human that you don't trust. The second thing I would mention, and this actually goes back to model safety as well, is pay attention to where you're actually doing your model requests. You can use, API keys to hit some of these like commercial services, but you incur a lot of risk if you sort of blindly go to like a Hugging Face or something and just grab a model, pick a model to call out to, because we have seen attacks that exist in that vein as well, where people are, using models that are like reporting information back to somewhere, or like aren't actually secure, and like are storing all of your, your messages and context and things like that. So the second question is, where are you actually doing your requests? Or like, where do you understand, you have full confidence in the trustworthiness of the model that you're using? And often the right choice is like something self-hosted. And in fact, it's actually, what we do with Midas as well, right? We built Midas because we wanted a tool that helps us or allows us to go and expect good performance out of models that maybe aren't as powerful as the flagships, because that's a lot of the more secure implementations and deployments.
And Tyler, if there was one thing you wanted leaders to remember as AI becomes deeply embedded in mission critical systems, what would that be?
I would want them to remember that they should always be able to understand and trace what their AI has been doing. They should remember that AI will not always make the decisions that they want made. And the way to understand that and the way to correct for that is to have a recorded history across the organization of what the AI has been asked to do and then what it really did.
Yeah, auditability is a requirement in a lot of places as well.
And that audit trail itself is training data for the humans that are doing work with the model, because it tells you, if something happened that you're not comfortable with, that's a control you have to build in. That's a structural change you have to make. If you don't want it making external network calls, you need to not give it the ability to do external network calls.
Thank you, Tyler and Austin, and thanks everyone for joining the conversation today. I loved our explanation of how Midas brings control to AI in mission-critical environments. And I think it's really important to talk about how AI capability is advancing quickly, and the challenge for organizations is making sure that governance advances with it. So for everyone, if you're ready to go deeper, schedule a governed AI briefing with our team.